Let's take a look at the last problem here that's got a bunch of pieces. Again, let's take a look at this next problem. Let's start by tracing it from left to right. So we'll start out with this first piece from left to right. Notice the first piece we're going down from left to right. So that's our piece that's going to be considered decreasing. Well, it starts off all the way with an arrow on the left side, so a negative infinity 2. Well, to the point, even though it's not there, I still need to know where it is, and we're reading it from left to right, so I'm going to use my x value. So up until that big hole we've got, I am decreasing or going down, which the hole is at negative 3. And again, no matter what, even if that hole wasn't there, we'd still be using parentheses because we're discussing increasing, decreasing, and constant. Okay, we've got one more piece here in the middle, which is, if we start with this next little piece in the middle, notice it's flat, so that's our piece that is constant. So reading that piece from left to right, using our x values, well, the first point starts at negative 3 and it ends at positive 3. So that means when we're constant, it's going to be from negative 3 to positive 3, and again, we'll use parentheses. And again, this has nothing to do with the points. Remember, if it's increasing, decreasing, or constant, we always use parentheses, no matter what. Last piece here. Notice the last piece here is going up from left to right, which means that's our last piece, and it's increasing. That last piece starts at an x value with a point of 3 and continues on forever because of the arrow, so towards infinity. And again, we use parentheses because we're always using open intervals for increasing, decreasing, and constant. Next one, domain. We're going to be looking at our graph from left to right. Well, if you actually read your graph from left to right and you look at its domain and say, where do I have a graph? There's only 2 possible problem spots. And the first problem spot is where we've got our hole. And the next problem spot is where we have what's called a jump. The first problem where we've got the hole here at negative 3, there isn't a graph there. So I need to leave that out. So I do have a graph all the way on the left from negative infinity up to negative 3, but there is no graph at negative 3. There's a big hole there, so I have to leave that out. I have to use an open set of parentheses. Union, then I also have a graph in between here. That's okay. From negative 3 to 3. Again, I'll use my parentheses. So now my next question is, what's happening at my second spot at 3? Do I have a graph there? Well, if both of those points were open circles, the answer would be no, that there's no point, there's no graph there. However, I actually do have a graph at 3 because there is a closed circle somewhere. So when you're asking for the domain, I can plug in 3 to my function because there is a graph there. So I'm going to ignore 3. 3 is okay. And the graph does continue upward forever, so it does continue off towards positive infinity. So the only value that got left out of the domain is negative 3, and that's because it had an open hole there. It didn't have a point anywhere, up or down, at 3. Now let's take a look at the range. The range is going to be a little bit trickier, just a little bit. We'll start at the bottom down at negative infinity and work our way up towards positive infinity. Let's see where our graph starts. Working our way from the bottom up, what we'll notice is the first part where we see our graph is here at, what's this y value? The y value for that point is here at 1. Now notice that there is an open circle. There's no point there. So I'm going to have to use a parentheses no matter what there. Now, it doesn't matter what's going on in the middle as long as there's a graph somewhere, and because this part of the graph does continue on forever, I will have a graph everywhere. So I'm going to go ahead and say to infinity. But I had to leave one out because there's technically no graph there. So it doesn't matter with the range that this part of the graph is confusing, because all that matters is that there's a graph somewhere, and there is. So I can just keep on going. This next problem, we're going to look at reading a graph and making sure that we can read a graph to answer a couple questions. Let's take a look at this next example. When a drug is taken orally, the amount of drug in the bloodstream after T hours. So the first thing that we're looking at is the amount of the drug in the bloodstream after T hours. That's what's going down here, is how many hours along the x-axis, but we're calling it T, and it's in hours. Okay, the next thing that we're going to look at is going along the y-axis is how much of the actual drug is in your bloodstream, which is going to be in, let's see, they didn't tell us what kind of units, they just said units. So now they're going to ask me a couple of questions I can hopefully read off my picture. So the first thing is, how many units of the drug are in the bloodstream at 8 hours? So that means I'm going to go over to where the 8 hours is and find out where my graph is, which is right around here, which is about halfway between 32 and 16. Well, halfway between 32 and 16 is 24. So we're going to go ahead and just say 24 units. And we're just approximating, but that looks very close. And the next one, during what time interval is the drug level in the bloodstream increasing? So one thing at a time. When am I increasing? Meaning, when is my graph going up? Well, my graph is going up or increasing on this first piece up until I hit this top part, which is happening at 2 hours. So, during what time interval is the drug level in the bloodstream increasing? Well, it's increasing for the first 2 hours. Okay, then the question is, when is it decreasing? Which means, when is it going down? Well, that's the rest of the graph would be. When is it decreasing? It'd be after 2 hours. So if you wanted to write this in a more mathy way, the first 2 hours would be anything from 0 to 2. And the other one would be anything from 2 to 12. And the reason why I'm cutting this off at 12 is because that's when our graph cuts off. It doesn't really make sense to really go past this, because eventually this will be out of your bloodstream completely. And when you're talking about time, your graph should end at some point. So that's why our graphs don't technically go on forever in real life situations, because it doesn't make sense. The next thing that they ask us about, which we're going to see off and on throughout this course starting now, is talking about our maximum value. Well, maximum value is where you have your highest value, your peak, which on this graph is up at that point, up top. And they said, when does it reach that peak? That means how long, when, at what time. So when does it reach that maximum value? We said it happens at 2 hours. And then it asks you a second question, which is, okay, after you find out when it happens, they also want you to figure out how many units are actually in the blood at that time, which is going to be your height of your function, which is your 64. So at 2 hours, it reaches a maximum of 64 units. And for us, we don't know what they're talking about. They didn't really tell us what kind of drug it was, what the units were. So we're just leaving it very vague, just like they did. Now, the next question is, when the drug reaches its maximum level, which we said happens when the drug reaches its maximum level, happens here at 2 hours, right here. They ask now how many additional hours are required for the level to drop to 16. How many additional hours are required for the level to drop to 16 units? So where am I going to hit 16 units? Let's see. So let's find 16 units. Happens here. And let's draw a line here. So how many hours is that from where I reach my maximum to here where I hit 16 units? Well, let's see how many hours there are from one side to the next. That's what they're asking us to find out, is how many hours from there to there. Well, we went from 2 hours to, it looks like, 10 hours. So how many additional hours? That means how many from where you started to where you're going to go that's an additional 8 hours. Because you went from 2 to 10, so there's 8 hours that you need to give it time to actually drop to the 16 units. So this last little part was just making sure that you understand how to read increasing and decreasing off of a actual real life situation graph and interpret what it means.